All right, just want to go through the density notes here. We're in our last part of the matter unit. And so density, we've talked about it before, but now we're going to go in a little more depth and learn how to find it, calculate it, and do some problems. So first couple of questions here. We've got to fill in some terms. So the amount of matter in a substance, that would be mass. The amount of space that a substance occupies, so space, that's going to be volume. And mass per unit volume, measure of how tightly packed the molecules are in an object, that is density. So none of these terms should be new to you. We learned them all when we learned about properties of matter. So these are those three terms, and they're going to be important to what we talk about for the rest of these notes. Density is the amount of matter within a certain volume. So which image here shows a substance that is more dense? Okay, the one that has more tightly packed particles is going to be the one here on the left. Okay, so if you look at the one on the right, you can see there's these empty spaces. So that's not as dense as this one here. Okay. In general, solids are more dense than liquids, which are more dense than gases due to the spacing between particles. So solids tend to be the most dense, and gases are the least dense. And then liquids are in the middle. And this is talking about for the same substance. Okay, so if you melt down a substance and compare the solid to the liquid, the solid tends to be more dense. And if you have a liquid and you boil that substance, the liquid tends to be more dense than the gas. Water is kind of weird because water is a little backwards, because we know that ice floats in liquid water. So solid water is less dense than liquid water. But the trend for most substances is that the solid is more dense than the liquid, which is more dense than the gas. Just water's backwards. Okay, so look at these two boxes here. Which one is more dense, and how do you know? Okay, well, they're the same size, but the one on the right has more particles in it, and so that would represent that it had more mass. So they're the same volume, but the one on the right has more mass. And so you can see that the particles are more tightly packed in that one. So the one on the right would be more dense. So the boxes are the same size. Like I said, they have the same volume, but there are more particles in the box on the right. So that would represent that the one on the right had more mass. And you can notice that the particles are closer together. All right, let's look at this one. Okay, so which one is more dense here, and how do you know? Well, we can see that these boxes are different sizes. So the one on the right is a bigger box, and the one on the left is a smaller box. If you count the particles, they each have 5 particles in them. So they have the same amount of particles, which means that they would have the same mass, because that's what that's representing. But the one on the left is smaller, and you can see that the particles are closer together. So the one on the left is going to be more dense. And this is kind of like our, if you have a pound of bricks versus a pound of feathers. Okay, so this is like the feathers. Oops. Where they both weigh a pound, and this is your brick. Where they both weigh a pound, but the brick, you don't need as many bricks to get to a pound. Whereas feathers, you need many more feathers to get to a pound. Okay, so the feathers would take up more space because they're not as dense, and the brick is more dense, so you don't need as many. It doesn't take up as much space. So the box on the left is more dense. Boxes have the same number of particles representing the same mass, but the box on the right is, oh, that should say, yes, that should say on the left. Whoops. Is smaller, less volume, the particles are closer together. Little typo there. All right. So I didn't have a slide about mass because mass is pretty easy to find. You just put the substance on the balance or on the scale and it tells you the mass. But volume, we need to do, we have to find the volume. We can't just put it on the scale and get the volume. So for volume, units are either in milliliters or centimeters cubed. I'm just going to put over here on the side that mass, the units are grams, or G. Okay, so back to volume. So measured in milliliters or centimeters cubed, the units are equal. So we typically use milliliters for a liquid and centimeters cubed for a solid. Okay, but it really doesn't matter because the two are equal. So 1 milliliter equals a centimeter cubed. So if I had a centimeter cube that was a little container and I measured water in a graduated cylinder, okay, that looks pretty good. And I measured 1 milliliter of water and then I poured that water into the centimeter cubed, it would go up to, right up to the top. It would fill the cube. Okay? So 1 milliliter equals a centimeter cubed. All right. So if we have something like this, a rectangular solid or a cube or something like that, you can measure each side with a ruler. Okay? Measure each side with a ruler, and then you learn this in math class. But volume equals length times width times height. So then you would multiply all of your measurements. Okay, so let's add some fake measurements here. So let's say that this is 6 centimeters. This can be 3 centimeters, and this one can be 2 centimeters. Okay, so to find the volume, we would do 6 times 3 times 2. Okay. So 6 times 3 is 18, times 2 is 36. So the volume is 36, and the units are centimeters cubed. So like I said, for a solid, we typically use centimeters cubed. And the reason it's centimeters cubed is because each side is measured in centimeters. And so you're going to do centimeters times centimeters times centimeters. So you're doing that 3 times. So centimeter cubed is how you get that unit. Okay? You can do that for a cube too. This was just a rectangular prism. But a cube, the nice thing about a cube is that each side is the same. So you just do, if you had a cube where each side is the same, so let's say this is 1.5, you would just do 1.5 cubed. Not 1.5 times 3, but 1.5 times 1.5 times 1.5 if you had a cube, because each side is the same. Okay? Water displacement. So there's another way to find volume, and it's called water displacement. And how it works is if you have an object, you can place it in water, and then the water level goes up. And however much the water level goes up is the volume of the object that you put in the water. And we typically do this for an object that has an irregular shape, or if it'll fit in a graduated cylinder. Okay? So when the object is placed in water, it pushes the water out of the way and causes the water to rise. The amount the water rises is the volume of the object. You can subtract the initial water level from the risen water level to calculate the volume of the object. And because this is water displacement, even though we're looking at the volume of the object, what we're going to be reading on the graduated cylinder is the level of the water, so we're going to use milliliters for our unit. So let's look at an example. So here we have an object, it's a rock, you can see. The initial volume of the water is at 150. So we're at 150 is our initial level before the rock goes in. You have to record the initial volume so you can know how much the water goes up. If you forget to record the initial volume, you have to start over because we don't know where the water started at to see how much it rose. Okay, so now if we put the rock in the cylinder, you can see the rock's there at the bottom. Okay, remember, we were at 150. All right, and you can see that the water has gone up. So it's now at 180. So I'm not saying that the volume of the rock is 180, but the water is now up to 180. Okay, so the volume of 180 milliliters is the water plus the rock. And if I go back a slide, I can see that the 150 is just the water. So the water level has there's 150 milliliters of water in here. And the water in the rock is 180. So if we subtract those two volumes, 180 minus 150, that'll tell us just the volume of the rock. So remember, the 150 was the water, and the 180 was the water and the rock. So if you subtract the water and the rock minus the water, you get rid of the water, and we're left with just the rock, which is what we would care about. So the rock is 30 milliliters, 180 minus 150. Okay, so we need volume so we can calculate density, right? Because density is mass divided by volume. Or the equation is m over v, if you're looking at just the variables. Some of you may have learned the saying that Dan is the man on the van. As a way to remember the formula, or some of you may have learned the broken heart method. This looks like an M, and this looks like a V. So either way is fine. The units for density, the units for mass are grams, and then you divide. The units for volume are milliliters or centimeters cubed. And again, these two things are equal, so you might see them listed, and don't let that confuse you, either one, because they mean the same thing. Because remember that 1 milliliter is the same thing as a centimeter cubed. Okay, so those are the units for density. So this is the process that you would do in the lab if you needed to find the density of something. First, you'd have to find the mass. You put it on the balance, and that would give you the mass in grams. Then you would find the volume. If it's a cube or a block, you can use length times width times height. That'll give you centimeters cubed. Or if you use water displacement, that'll give you milliliters as your unit. And then calculate density, you do the mass divided by the volume. So you're going to do the grams divided by the centimeters cubed, or grams divided by the milliliters for the density. So either way. So you first find the mass, because that's usually the easiest thing to do, just put it on the balance. Then you've got to determine the volume by measuring with a ruler all the sides, or using the water displacement method, and then you can calculate the density. So a few practice problems here. A 2,750 gram sample of a substance occupies a volume of 250 milliliters. Find its density in grams per milliliter. So on the bottom right, I have an equation triangle. And how this works is it's set up for the equation. So we know that density equals mass divided by volume. Okay, so if you were finding, if you needed to find density, you would cross it out, and that leaves you with mass divided by volume. If you needed to find mass, that would leave you with density times volume. And if you needed to find volume, that would leave you with mass divided by density. So how the equation triangle works is you cross out whatever variable you need to find, and if it's next to each other, then you multiply, and if it's on top, you would divide. Okay, so the mass is always on top of the equation triangle because it's mass divided by volume, and then that also works out. It kind of helps you. You don't have to do any algebraic rearranging of the equation to find any of the other variables if I would ask you that. Okay, so a 2,750 gram sample. So this, I like to do some underlining and looking at the units. So there's a number, here's a number, and I always try to focus on what it's asking me to find. So here it says find its density. So I'm going to be looking at density. So I'm going to cross density off. So I know I'm going to do mass divided by volume. Okay, now looking at the equation, let me move this down. Looking at the equation, I have two numbers, and I need to figure out which one's my mass and which one's my volume. Well, mass is always measured in grams, so the one that has the G is the mass. Okay, so that's my M, and then the milliliters is volume, so that's my V. So always look at units, and also there might be a hint in the question, like this says a volume of 250 milliliters. Those hints and things won't always be there, but when they are, take advantage of them. Okay, so mass is on top, so 2750 divided by the volume is 250. Okay, so density, when you plug that in the calculator, 2750 divided by 250, you should get 11. And the units are going to be gram over ml, just like they wanted. So grams over ml. So that's how that unit is. It's there because you're doing mass divided by volume, so grams divided by milliliters. So that's why the units for density are the way they are. Okay, on the next slide we can just kind of check our work here. So, yep, that's what we got. Practice number 2, given a brick. So I'm going to go and draw my brick. If you're a visual person, like I kind of am, then go ahead and draw this out. Draw out a visual here. Okay? So given a brick with the sides of 3 centimeters by 2 centimeters by 1.5 centimeters. Find its density if the mass is 200 grams. The mass is 200 grams. Okay, so we need to find the density. So find the density, so I'm going to do this. So I know I'm going to do mass divided by volume. So density equals M over V. The mass is 200 grams, because it's the G, divided by the volume. Now, I don't see anything with centimeters cubed or milliliters. I see centimeter, 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 and I got a brick. So I know what I need to do is I need to use volume equals length times width times height. So I need to multiply those 3 sides together to get the volume of the object before I can find the density of the object. Okay, so volume is going to be 3 times 2 times 1.5. Now it doesn't matter the order that you would multiply these. You could do 1.5 times 3 times 2. It does not matter the order. I'm just going in the order that they were in the problem. But because you're multiplying them all together, it does not matter the order that they go in. So 3 times 2 times 1.5, if you plug that in, that will give you 9. And it's going to be centimeters cubed because you're doing centimeters times centimeters times centimeters. All right, so this is V is 9. So when I use my equation for density, I'm going to put 9 on the bottom because V is 9. I just calculated that, so that number goes in the bottom. It's very rare that you would have to do a calculation like this and then not use that number. Usually when you do a calculation like this, then you use that number that you calculated in the next problem. That's typically when you have a multi-step problem like that. That's how that goes. Okay, so 200 divided by 9 is going to be 22.2. The 2 repeats, you can just leave it at, round it off at 1 decimal. Grams divided by centimeter cubed. Okay, because it's grams over centimeter cubed. And then we can scroll down and check our work. Volume is that. Density is that. Good to go. Our last practice problem, it's got 3 parts. The first 2 are here on this slide, and then once we solve it, we have another question to answer about it later. But a small piece of metal has a mass of 16.85 grams. It is placed in water in a graduated cylinder that has an original volume of 15 milliliters. The water rises to 16.9 milliliters. What is the volume of the object? That's the first part. What is the density of the object? That's the second part. So we want to find the volume and what is the density. Okay, so the process that they used to get the volume was they took the piece of metal and they put it in a graduated cylinder that already had water in it, and then the water went up to 16.9. It started at 15. So that process, remember, is water displacement. So they used water displacement to find the volume. And so what you want to do to get the volume of just the object is you want to subtract your 2 volumes. So this is a volume here, the 16.9, and this is a volume here, the 15.0. Okay, so those are the volumes because the units are milliliters. So we're going to do 16.9 minus 15.0. Okay, so 16.9 is the water plus the metal. Okay, and the 15.0 is just the water before the piece of metal was in it. And if we subtract those 2, we get rid of the water and we'll get just the mass of the metal object. Okay, so that would be 1.9 milliliters. So that is the volume of our object. That's part 1. Okay, now the next part says, what is the density? Okay, well, we're going to do mass divided by volume, cover up density. Remember, you can't use the equation triangle if you're missing more than one variable. You can only use it if you're only missing one variable. So we couldn't use that for volume. We had to use water displacement to find volume. Now we can use it to find density. So density equals mass divided by volume. This was our mass up here, 16.85 grams. So we know that's a mass. So that's going to go in for M. Okay, now what value are we going to use for volume? Are we going to use 15 milliliters, 16.9 milliliters, or 1.9 milliliter? We're going to use 1.9 milliliters because that's the volume of just the object. Remember, 15 milliliters was just water, 16.9 was water and our object. but 1.9 was just our object. Okay, so you're going to plug that in and calculate. So 16.85 divided by 1.9, rounded to 2 decimals, is 8.87 grams per milliliter. Okay, so that is the density of our metal. Okay, so water displacement got us a volume of 1.9, and our density was 8.87. And the last part of this is, so this was our density of our piece of metal, and they want to know which metal is most likely the one in problem number 3. Below are the densities of several metals. So density is a characteristic property, and that means that it can help us identify a substance. So just like melting point and boiling point, those are unique to a substance, and it doesn't matter the size of the sample, those properties stay the same. So density is one of those properties. So 8.87, our closest known density is copper's density, which is 8.96 grams per milliliter. So our metal is most likely copper. And so we can scroll down to check. So yes, density is a characteristic property and can be used to identify substances. The metal is most likely copper because the density of copper is the closest to our calculated density from the problem.